Welcome back, Calculus. We're going to continue the related rates problems. And again, most times they will give you the formula. In this instance, I'm going to tell you the formula. But again, if it's a take-home test, you might need to look it up. Or if it's in class, just give me a heads up and I can answer that question. So in this problem, we're just dropping a ball or a stone, into a pond, or whatever calm body of water is, to make concentric circles. In case you have forgotten from geometry, concentric circles share a center. So as the ripples go out, you can see concentric circles. And they tell you the radius of the outer, so R, is increasing at a rate. So if you followed the notes from the first video, that we're going to use dr dt, 1 foot per second. And you might want to write those units down so then you're not confused at the end what the final answer is. So that is moving continuously. Okay, when the radius is 4 feet, R equals 4, what rate is the total area disturbed water changing? So as I'm looking at this, because the question says area, I would want to investigate a formula for area, which is actually kind of step 4 here. And in case you've forgotten, this area of a circle is pi r squared. So we know the r, we know dr dt. Are there any constant variables? Well, technically no, although some of you might be saying, well, pi is always 3.14, so it is a constant. I'm trying to think what else. And what are we trying to solve for? What we wish to find would be dA dt. And maybe I should have color-coded this a little bit, because it's asking at what rate is the area. And while I'm at it, I might as well talk about, well, what kind of answer will we get if we're asking for the rate? It needs to be units. The time is measured in seconds. Now, area is in square units, so it should be in feet squared per second. That's how I do the problem. So let's continue on. So as we implicitly differentiate both sides, this is actually the next box, but I'm just writing it right here. dA dt would equal 2 pi r dr dt, because that is the derivative of both sides. And now we can plug in 1 for dr dt. We can plug in 4 for r. We still have 2 times pi, and it will equal this. Now let me put the units back in there to help you out. I'm going to go to orange. The radius was measured in 4 feet at that moment. And dr dt was measured in feet per second. So as you multiply, I think most of you would probably look at this and say, oh, well, 2 times 4 is 8 times 1 is not going to change the value of it. So we're looking at 8 pi, and now looking at those units, you can confirm that feet times feet is feet squared per second. And that's what your answer will be for dA dt. So as you get better at this, you might not need as much room, as many boxes on here. Especially when they give you the formula, sometimes you don't have to think too hard to get to that correct answer. So again, your clues are in the problem. A cylindrical tank. The water's leaking out, so that's important. And it's 3 cubic feet. So if you didn't pick up that they were talking about volume in there, think about how we measure volume in cubic units. And it's going to be -3 because it's leaking out of cubic feet per second. Okay, if you missed that, it was a rate. This word right here also is a clue that it's a rate, per. So if the radius of the tank is 4 feet, so we can write that down, r equals 4 feet. At what rate is the depth of the water changing at any instant in this problem? Well, if you were to look at the directions, identify all the variables. Well, you might want to identify that it's a cylinder. So look at volume is equal to pi r squared h. But in this problem, r, the tank is not changing sizes. All it's doing is the depth is going down. So is anything a constant? This time r is a constant. R is 4. So the formula we're actually looking at is 16, because 4 squared is 16 pi h. And what are we trying to find? We're trying to find the depth of the water is really h. I should change colors. The depth of the water is really h, and we want the rate. So we want dh dt. See, I think I've written everything down. I know what r is. I know what dv dt is. Alright, so let me just rewrite that equation again. V equals 16 pi h. And now we know we can take the derivative of that. So dv dt is equal to 16 pi dh dt. And that's why you didn't actually, that's why the directions said at any instant, is it does not matter what h is. Does not matter the height or depth. And the reason for that is it's decreasing at a constant rate. So think of it that way. So let's actually plug in with the correct unit. So it's a -3 cubic feet per second. And maybe I should have mentioned it here, but so R was 4 feet. So really what I should have done is plugged in 4 squared and feet squared. So that's really 16 square feet times pi times dh dt. So then it makes sense, at least it makes sense in my head, that as you divide all of these pieces over to solve for dh dt, what do I want to say? So not only do you divide the 16, the pi, but you also divide the square feet. So 2 of those feet will cancel, and your answer will be feet per second. And I don't know what -3 divided by 16 is. You can use a calculator, or if this were a no calculator test, they would actually just leave the answer like that, which is perfectly fine. Yeah, and that does make sense. If you had a cylinder that was leaking out, something at the bottom, let's say you had a hole down here, you would probably expect that the height would be going down because it's negative at a constant level. Just going on from there. So here's another problem. We involve a cone. Its diameter is 10. Might be worth mentioning that its radius is 5 and its height is 15. Water is being poured into the cone so that the height of the water is changing. Ooh, that's pretty good. So that tells me that dh dt is 1.2 inches per second. Units are important. Maybe I should have mentioned that up here. Inches, and height is in 15 inches. At the instant when the radius of the exposed surface area of the water is 2 inches, at what rate is the volume of the water changing? So the way I'm reading this is, I know you kind of have to infer that it is an upside down cone, but the AP test does a really good job of making sure you understand what kind of cone you're looking at. So the way that you need to infer something here is that on all cones, the triangles inside of this cone have to be similar to each other. So what do I mean is if the total radius is 5 and the total height is 15, then let me just redraw like a smaller version of the cone. Because we, at the instant when the radius of the exposed area is 2 inches, so that little piece is 2, well, the height has to be similar to this. So you would probably set up a proportion. I don't know how you learned this in geometry. Maybe do 5 over 2 equals 15 over x. I don't know if that's how you would do that. Maybe you would even do it this way, where you multiply by 3 here, so x needs to be a height of 6, because you have to multiply by 3. Or however you solved it, just make sure that your height in this problem needs to be 6. Yeah, I like that. So what do we know? We know the radius. Well, I feel like this is not real. Like, this is needed to figure out this situation at the instant. So the radius in the problem is actually 2 inches, when the height in the problem is 6 inches. Let's see, they tell you the height in the problem. So let me circle this. That sort of goes right here as well. And what are we trying to find? The rate. Let me change colors again. The rate. The volume is changing. So we want volume of a cone. That's that 1/3 pi r squared times h. I kind of wrote that in the wrong spot, but I don't think, I guess technically pi is the constant variable. What are we trying to find is dV dt. Remember your units on this, so let me just put like a squiggly blank there. It should be in cubic inches per second. So as we look at this problem then, we know dH dt, but we don't really know what dr dt is in the problem. But what we do know, stick with me here, is something's a constant, isn't it? That there's definitely a connection between the radius and the height. All right. I went to the answer key and noticed that I recorded this problem and did something incorrect. So now I'm just going to the answer key and showing you. It was a very minor mistake, but it would take me a while to fix it. So everything I said was correct. This is sort of how this author comes up with the problem. So I clearly do the problem different than he does. But I made a drastic mistake. Is I labeled over here that the height was changing it was dH dt, and then I solved the problem as if it was dr dt, which was a huge mistake. So I'm just showing you how you could fix this. So I was on the right track of that connection between R and H, that if you triple R, it equals H. Well, if you go backwards, it's 1/3 of R. 1/3 of H gives you R. So that's where this connection comes in right here. So then you can simplify that problem, and he works it out as well in this. Again, pause the video if you are stuck on any of the math, but that was the main thing there. And come to class with questions if this is confusing. We can work it out in class as well. That way you can simplify the problem, so then you can take the derivative of the left side, which is dV dt, the derivative of the right side, bring the 3 in front. 3 times 1/27 is 1/9 pi h squared dH dt, and you can plug things in. So at that moment that the radius was 2, the height was 6. So and it's in inches. So 6 inches squared would be 36 square inches. 1.2 is in inches per second, so inches squared times inches is inches cubed per second. And apparently 36 divided by 9 is 4.8. So I'm going to stop the video here. I have lots more to talk about with related rates. And as you can tell, this is not the easiest of things. One small mistake will drastically change your answer.